Hello and welcome to this lesson, which is all about sharing because we are looking at covalent bonding. Now, up to now, we've looked at ionic bonding, where an electron is transferred from one atom to another atom. We're going to start by having a look at some ionic compounds and see how we decide how many of each atom are in the compound. So if we look at calcium chloride here, calcium makes 2+ ions. Okay, so it's got 2 positive charges. Chlorine makes 1- ions. So in order for it to balance out to 0, you need 2 lots of the 1- to cancel out the 2 pluses, which is why it's CaCl2. Okay, let's have a look at iron bromide, which is the first of these that you need to do. Iron makes 3+ ions. Okay, so it's got 3 pluses. Bromide is 1- ions. So you need 3 bromide ions, you need 3 negatives to cancel the 3 positives. So the formula for iron bromide is going to be FeBr3. Okay, pause the video, have a go at the rest of these, and then we'll go through them. Okay, so aluminium nitride. Aluminium is 3+, nitride is 3-. So the 3 pluses there cancel out with the 3-, so we just get Aln. Sodium oxide, sodium is 1+, oxide is 2-, so we need 2 pluses, 2 lots of sodium to cancel out the 1 oxygen, so it's Na2O. Lithium bromide, lithium is 1+, bromide is 1-, so that cancels out, LiBr. Calcium nitrate, calcium is 2+, nitrate is 1-, so we need 2 lots of nitrate to every calcium. Now you'll notice that the whole of the nitrate is in brackets, so the 2 refers to the whole of the NO3. There's 2 lots of all of that. There's in each of those lots there's 3 oxygens and 1 nitrogen. Okay, if we move on to sodium sulfate, sodium is 1+, sulfate is 2-, so we're going to need 2 sodiums for every sulfate, so that's going to give us Na2SO4. And we don't need brackets around that because we've only got 1 lot of the SO4. Okay, let's move on to look at when we're going to have different compounds. Which of these compounds have ionic bonding? Sodium chloride does, water doesn't, magnesium oxide does, lithium oxide does, carbon dioxide and methane don't. And the reason for that is the ones with ionic bonding have a metal element and a non-metal element joined together, whereas the others have 2 non-metals. So, pause the video for a minute to copy this down. Ionic bonding occurs between metals and non-metals. So in any ionic substance, you've got some metals and some non-metals. Covalent bonding always occurs between 2 non-metals, and they can be the same element or different elements. And it's present across a wide range of substances with small molecules. Okay, so in covalent bonding, what's happening is the electrons are being shared between the atoms. And a covalent bond is a shared pair of electrons. So if we start with a hydrogen, that's got 1 gap. Another hydrogen can join that, they can share electrons, and both of them then feel like they've got 2 electrons in their outer shell, which gives them a full outer shell, so they become stable. Okay, we can draw that in a variety of ways. So we use dot and cross diagrams where the dots and crosses represent the electrons, or we can use molecular formulae, which is H2, or the structural formula, which is an H with a line and then another H. So each bond is represented by a line. If we wanted to draw the bond formed by the fluorine molecule, well, fluorine is F2, so we start with 2 fluorines, and then they're going to come together to fill that gap in their outer shell. Okay, so they share 1 pair of electrons, so that each of them thinks they have 8 electrons in their outer shell. Okay, next task, draw the electronic structure of fluorine and of hydrogen. So pause for a minute and have a go at that yourself. Okay, so let's start with fluorine. Fluorine, we know, has 2 electrons on its inner shell, and it has 7 on its outer shell, okay, giving a total of 9 electrons. And we usually draw them in pairs when we're drawing out the electrons. Okay, then we've got hydrogen, which has 1 electron in its outer shell. Okay, so fluorine has a gap. Hydrogen also has a gap to be able to create a full outer shell. So those can come together in order to share a pair of electrons. So if we're drawing that as a hydrogen fluoride, they come together like that. Okay, the outer shells overlap and the electrons are shared, so they both have full outer shells of electrons, making them nice and stable. Okay, so your next task is to draw the dot and cross diagrams for a variety of different compounds on here. So we're going to start with water, and we're going to do that one together to have a look at how you do it. So water, we know, is H2O. So we need 1 oxygen and 2 hydrogens. We draw out the atoms first. Oxygen has 6 electrons in its outer shell, so 2 gaps. Hydrogen has 1 gap. So each of those hydrogens can join onto the oxygen to fill a gap in the outer shell. Okay, pause the video for a moment and have a go at drawing the other compounds and elements that are mentioned in the questions. If you can do extension 1, that's great. Extension 2 is really tricky, but have a go. Okay, so if we have a look, here we've got methane. So for methane, the carbon has 4 gaps. Each of those joins with a hydrogen to create a pair. Then if we have a look at ammonia, ammonia starts off with a nitrogen. It has 2 electrons on its inner shell. And nitrogen has 5 electrons on its outer shell. It's got 7 electrons in total. So each of those, of the 3 gaps to make the complete 8, can share an electron with a hydrogen. So we get the NH3 of ammonia. Okay, moving on. Slightly trickier one, oxygen. It's got 2 gaps in its outer shell, so 2 pairs of electrons get shared, so that each oxygen thinks it's got a full 8. Okay, if we have a look at nitrogen, each nitrogen has 3 gaps in its outer shell, so that they need to make a triple bond, sharing 3 electrons. Okay, here we've got the ethene diagram. It's actually got 1 pair too many electrons in the middle there. We've got ethyne, another one with a triple bond. Hydrogen cyanide, very deadly. Do not consume. And again, we've got a triple bond in there. And carbon monoxide, which again has that full outer shell with a triple bond. Okay, so what I want you to do now is copy and complete this table with which type of bonding we've got in each of these. So if we've got a non-metal and a metal, we're going to have ionic bonding. That goes in 2 boxes. If we've got a non-metal and a non-metal, that's covalent bonding. And metal is metallic bonding. Okay, have a go at PQ.